Suprasha on YouTube wants to know, how will NISAR be helpful for humankind?
So NISAR will be helpful for humankind by providing data and information that allows us to see what's happening from natural disasters. We've talked about the impacts of natural disasters. It will also help us see the small changes that are difficult to detect with the human eye that can impact the infrastructure on the ground, as well as measuring changes in soil moisture and changes in vegetation that help us understand how we grow food that we need to live. So lots of ways. Those are just a few.
Yeah. So NISAR will track small shifts in Earth's surface, detecting early signs of volcanic eruptions. Let's take a look.
One of the real key questions in our field of volcanology is to try to understand when is a volcano getting ready to erupt and when is something that we observe happening there just a natural process that isn't going to lead to eruption.
Deformation is often one of the first signs that a volcano is becoming restless, and then we also look for increased seismic activity. But the earlier that we can detect that deformation, the more we can refine what kind of a forecast we have and whether or not we need to be concerned about eruptions.
NISAR has a couple of capabilities that are going to be really transformative for volcanology. The first is the consistency. The fact that we're going to get these incredible data very consistently every couple of weeks. The other aspect of NISAR that's very important is its wavelength. It's got a longer wavelength than most satellite missions that have taken radars up into space, and that longer wavelength means that we're going to be able to penetrate vegetation and be able to see the ground through trees. We're going to get consistency, and we're going to get the ability to see through a lot of this obscuring vegetation, and that's really going to open the door for studies of volcanoes.
Because it's expensive and dangerous to put ground sensors around many of the world's volcanoes, many volcanoes around the world have no sensors on them or too few sensors to really understand what's happening.
Having something that's completely remote and satellite-based allows us to get an image of what's going on without needing to have something in the remote ground surface.
The thing about volcanoes is they can have a regional or even a global impact depending on the size of the eruption.
So it's really key to be able to understand how volcanoes work so we can better forecast their activity and warn people that might be impacted by eruptions.
And Sue, there are other natural hazards that NISAR can monitor as well.
Yes, and just recently, in the last few hours, there was a major earthquake in Russia, magnitude 8.8, and NISAR will be very important for being able to forecast as well as assess the damage caused by those types of earthquakes and the tsunamis that they can generate as well.
Oh, thank you for breaking that down for us, Sue. And NISAR's journey to the launch pad was a global effort. JPL built the L-band radar while ISRO built the S-band. The two were integrated at JPL into a single radar payload. That system, along with the boom and reflector, was then shipped 9,000 miles to India. In Bengaluru, teams from both agencies worked together to assemble and test the satellite. After final checks, it was transported to the Satish Dhawan Space Center in Sriharikota, India, for final launch preparations. This partnership brought teams together from around the world, including JPL systems engineer Akshata Krishnamurthy. She grew up in Bengaluru and has been traveling from California back home to India to support the mission. Let's take a look at part of her journey.
Hey everyone, I am at LAX right now. I just finished security and I'm ready to board. It's the first of 3 flights with stopover in Dallas, Doha, and Bangalore. This is where I grew up in Bangalore. It is amazing and nostalgic, in fact, to come here because it was my dream job to work at NASA. Now I'm able to contribute to my home country on a project where we're doing an international collaboration. So super excited to be a part of this effort and also grateful for this experience.
And just a few days ago, I had a chance to speak with Dave Gallagher, the new director of JPL, to hear his thoughts on launch. Dave, thank you so much for joining us today.
It's my pleasure, Raquel. I'm happy to be here.
From your perspective, why is NISAR such a groundbreaking collaboration between NASA and ISRO?
This is the single biggest collaboration in space between the United States and India. It's enormously important to both countries, and space diplomacy is key right now. One of the most challenging things about this collaboration is the difficult time zone. So we have our JPL engineers and scientists working shoulder to shoulder with their ISRO counterparts, and the team is just working fantastic together.
When people think of JPL, they probably think of Mars rovers or deep space exploration, but JPL is also dedicated to studying Earth science and our home planet. What do you hope NISAR will achieve that adds on to those many Earth missions?
Well, Raquel, just to build on what you said, we actually have 4 decades of pioneering missions to really understand our home planet, missions like GRACE, missions like EMIT, like SWAT, that are born here and really have turned out to be some of the most important missions in existence to understand our home planet. NISAR is going to give us an unprecedented view of the Earth, both our ice mass, land mass, and because it's synthetic aperture radar, which is a technology really pioneered at JPL, it can work day and night and through any kind of weather.
Can you tell us how the JPL team contributed to NISAR and what that says about JPL's history of working on international partnerships?
Absolutely. This will be the first mission to use 2 kinds of radar. The L-band radar is developed by JPL. The S-band radar is developed by ISRO. And that combination of those 2 radar systems will allow us an unprecedented understanding and view of the Earth. NISAR builds on JPL's long-standing legacy of working with international partners. We can drive innovation when we take advantage of each country's strengths. We are actually stronger when we work together than doing this alone.
So looking ahead, what kind of legacy do you hope NISAR leaves behind for future Earth science missions?
What I'm most excited about with NISAR is the real-world applications, things like infrastructure monitoring, natural disaster recovery and response, agriculture management. This is going to make a real difference for real people around the world.
Thank you so much for your time and insights today.
Thanks.
So Pradeep on X wants to know, how will NISAR's satellite be different from others, and what capabilities does it have which others don't?
That's a great question. So a key difference from NISAR is that it is going to be globally measuring at very high spatial resolution. So this is the technology or the capability enabled by the radar technology that is called SweepSAR, as well as the very large antenna reflector that we saw earlier. Another key innovation from NISAR is the dual band radar. It will be the first satellite to be measuring with both L and S band.
Nikki, thank you so much for joining us today.
Oh, you're so welcome. It's a great day.
NASA has more than 24 missions focused on Earth science right now. What makes NISAR unique?
We really don't quite understand why our planet is always moving. The surface of the planet is always kind of moving, and we can't detect it. But with this amazing technology that NISAR brings, we're going to be able to actually start studying these tiny little, almost landslides, these little tiny quakes. And the goal, of course, being that we find a signature that happens before a major disaster that would allow us to then look for that and search for it and almost be able to predict these big disasters before they happen.
And you mentioned those tiny changes that this mission will track. What kind of other insights may we gain that could help people in their everyday lives?
We're also getting the data into the hands of people that need it, the decision makers, the people who are working with the first responders to actually go in and help people once these disasters have happened. You mentioned how many missions we have in the Earth Science Fleet. And when you put all these missions together, you just get so much more out of them. And so having NISAR launch take its place in the Earth Science Fleet, really illuminating so much more about our home planet, NISAR NISAR is just going to give us unprecedented views to add to the information we have about our planet.
Rian on YouTube wants to know, how will ISRO and NASA ensure NISAR's data is accessible and useful for developing nations most afflicted by climate change?
Oh, that is a wonderful question. So NASA has an open science policy and open data policy. And so all of the data that NISAR will be collecting, all of that L-band data will be available through a NASA archive at the Alaska Satellite Facility, and then India will also be making their data available, the S-band data and L-band data that they will be processing, available and openly free and available to everyone through their data archive as well. So all of the data will be free.
Great, and we have a couple more coming in. Raul on X wants to know, why is NISAR's antenna so big compared to other Earth-observing satellites, and what is it made out of?
So I can answer the first question. I don't think I have the exact facts for the second question about what it's made of. But the reason why it needs to be so large is that area gives us the very high spatial resolution that is going to be unique to NISAR, combining that global coverage as well as the high spatial resolution. So we need that surface area to collect all the reflected radar signal from the Earth, focus it onto the receiving antenna, and that will give us the high spatial resolution.
Thank you, Sue. So Gene018 on YouTube wants to know, since NISAR uses both L-band and S-band SAR, how does the dual-band radar improve surface imagery accuracy, especially in densely vegetated and urban regions? These are some great questions.
Yeah, so how will the L and S-band radar help us improve the surface deformation?
Vegetated and urban regions.
Vegetated and urban regions. So that because the two different radars are different wavelengths, they will be sensitive to different parts of the vegetated environment, and so we'll be able to characterize the vegetated areas more accurately using the two different wavelengths.